On page 7 of our notes, we're talking about English engineering units, versus SI units. We use English engineering units, or this is also called like the imperial system. We use it commonly within the U.S. So in the United States, this is pretty common. This is like inches, feet, miles, that kind of thing. But this is really an inconsistent system. So even though this system is most commonly used in everyday society, it is inconsistent and difficult to manipulate. So I can zoom that for you. Inconsistent and difficult to manipulate. So in science, what we do is we use SI units. And SI units were created in 1960 so that scientists could have a common, agreed-upon system of measurement that's easy to manipulate. So common, agreed-upon system of measurement, easy to manipulate. So the SI system, we're using this system, uses prefix to denote the scale, which is how big or how small the magnitude of the measurement is. And then off to the right-hand side of this, I have this little chart. I'm going to put over it base units. It's an E. So these are all going to be our base units within our SI system. So the SI unit for length is going to be measured in M, which stands for meters. The SI unit for mass we've already used. What is G? Grams. The SI unit for time is measured in S, which is seconds. So a lot of them are really things you've heard of. I say that, and then of course we get to two that you probably haven't heard of, and that's okay. We'll work with them later on, especially throughout chemistry specifically, but also all of these units are used in any science. So K for temperature stands for Kelvin. It's Kelvin. N stands for, I say number of moles because students get confused why it's moles with an M. So it's basically number of moles for the amount of a substance. And then L for volume. Do you know what that stands for? Liters. Perfect. So meters, grams, seconds, Kelvin, and moles, and liters. Those are all our base units. And what we're doing when we're using SI units is we can add prefixes to them to tell you the scale, or basically a conversion factor of how many whatever it is. So let me give you some examples. There are 3 on here that I think are extremely important just for daily life that you have guaranteed already heard of. The first one is kilo, which means 1,000. The next one is centi, which means hundredth. And the next one is milli, which means thousandth. So we'll talk about kind of what these are. So notice that this is the unit. This means that this is where our base is. Anything up here is getting bigger. So bigger than the base unit. And anything down here is going to be smaller than the base unit. I'm just going to say smaller than, and then base is basically right there. And so what these things are telling you is that if something is like a kilogram or kilonewton kilometer or kilometer or kiloliter or kilosecond or whatever we put it on, any of the base units, that means that it is 1,000 times bigger than the base unit. And if something is a centigram or a centimeter or a centiliter or whatever it is 1/100th of the base unit. Or another way that we can think of that, I tend to stay away from these numbers and basically just always put it in a way that you can write it as a whole number. And I'll show you what I mean by that. But what this means is, I'm going to put a different color. So centi is 100 times smaller than the base unit. And milli is 1,000 times smaller than the base unit. And kilo is 1,000 times bigger than the base unit. So any of these things are getting smaller than the base, any of these things are getting bigger than the base, and we'll kind of work on it from there. So the three that I want you to memorize are the three that I have highlighted because those are the ones that I think are most common, kind of just in our everyday lives. Anything else, I'm not saying we won't necessarily use them, but if I were to ask you a question regarding any of the other prefixes, I would give you that conversion factor. So when I say conversion factor, I'm talking about basically these charts up here. I'm not going to give you the conversion factors for any of the ones I ask you to memorize. So let's go to this little part here. I want you to memorize them. So when we're looking at these, the first thing that I think that it makes sense for you to do is between milliliters and liters, which one is bigger? Is a milliliter bigger or is a liter bigger? A liter is bigger. So next to the bigger one, put a 1. And then the question becomes, how many milliliters are in 1 liter? So if we're using our little chart here, hold on, I'm asking you to guess. A milliliter is going to be 1,000 times smaller than the base unit, which tells us that there are 1,000 milliliters in 1 liter. So I write it this way because these numbers tend to get really confusing for students. So another way to say this is that this number is equal to 1 liter, but I think it makes more sense when you see it as the whole numbers. So if you ask yourself every single time which one is bigger, put a 1 next to whichever one is bigger, and then use the prefix to tell you how many of the little thing are in the big thing. So let's try it again for other ones with the prefix milli. So if I go to millimeter, it's the same prefix. So millimeters versus meters. Which one is bigger? Meters, because that is my base unit. How many millimeters are in 1 meter? It's the same number as before. 1,000. Perfect. If I jump to this one, that's milligrams to grams, which one is bigger, a milligram or a gram? A gram is bigger because that's my base unit. My milligram is going to be 1/1000th of a gram, meaning that there are 1,000 of them in one of my base unit. Make sense? So we will use these in our T-charts when we're doing conversions. And I won't give you these conversion factors because it's in the name. So to go from liter to milliliter, you need to know that the milliliter is smaller, or the millimeter is smaller, or the milligram, or the millisecond. Those are all smaller than the base unit every single time. Good? All right, next one I have, let's do kilogram. So kilogram to gram. So this one, I said kilo is 1,000 times bigger than the base. So which one's bigger, a kilogram or a gram? A kilogram is bigger. Put a 1 next to it because it's bigger. Then the question becomes, how many grams are in a kilogram? 1,000. Perfect. And then kilometer or a kilometer versus meter, which one is bigger? Kilometer is bigger. How many meters are in a kilometer? 1,000. So you're getting the pattern. And then the last one that's on our list to memorize is centimeters to meters. So from centimeters to meters, which one is bigger? Meters. And then centi means 1/100th. So there are 100 of the smaller things in the base unit. So how many centimeters in a meter? 100. And then this last one, I just put it on here because it's another one that I'm asking you to memorize because we're going to use them a lot. So I'm going to give myself a little space down there to write. We have already written this conversion factor on multiple pages. A centimeter cubed, 1 centimeter cubed is equivalent to how many milliliters?
1.
Just 1. Perfect. This is just a volume conversion. So if you see something, so for example, we measure density usually in grams per milliliter, or we can measure density in grams per centimeter cubed, and it means the same thing. So if I give you density in this unit, you can put it as density in this unit because it's the same exact thing. If I give you density in this unit, you can put it in that one because it means the same thing. So there's a question like this on your homework assignment that requires you to know that those are the same exact thing. Same thing with volume. So we've written that, I think, 3 times now in our notes. Cool? Questions about any of those? Awesome. I'm going to stop the video and start a new one.